Calculus BC, we're in the last lesson of Chapter 4, 4.9, Antiderivatives. And honestly, this lesson in many textbooks is actually just covered in the next chapter. But our author does something neat. He is doing this little introduction of this topic that will play such a huge role in the next two chapters. So an antiderivative, obviously if we were to just go back and think about what's happening here, if we first reviewed how to take a derivative, imagine that I had y is equal to x cubed, you'd say, well, y prime, what did we do? We brought our power down and then we subtracted by 1. 3 minus 1 is a 2. Imagine if we wanted to work in reverse. What if we'd want to start here and then move backwards? This would be called an antiderivative. You can see essentially what we're going to do is, again, focus on the power, but instead of subtracting 1, we're going to add 1 to that power. We'd wind up with x to the third, and then we'd divide by that new power to cancel out whatever we had here. So that's the key to doing an antiderivative. We're going to bump our power up by 1 and divide by that new power. So you could see what would happen. This would become x to the third, but then we'd have to divide by that new power of 3, and sure enough, you'd be right back to where you started. So that's the main idea. Here's what is maybe a little disappointing, and Dr. Stewart isn't the only author who does this. An antiderivative is sometimes represented by a capital letter F. So we've got little f of x, so capital F of x would be a way to say, find this antiderivative. And if that's the case, here's the cool thing. If you found your antiderivative, you can always check if you're right by taking the derivative of what you just found. You should go back to little f of x. Here's a huge theorem, though. If f of x is an antiderivative, then the most general antiderivative of f would be capital F of x plus a constant, c. And c is an arbitrary constant. It's just some number that could represent positive or negative constants. Think about it. If we had a plus 5 or a minus 17, take a derivative of that and it will disappear. Well, the best thing to do, I think, is just to start doing some work to find general antiderivatives. Here we have f of v instead of f of x, so I'll say capital F of v. What do? We take our power and we add 1. Well, what's 5/4 plus 1? Well, 5/4 plus 4/4 is 9/4. But then I'm going to have to divide by that new power. I come over here and v to the 1/4. Well, I'm going to have to add a 1 to that. 4/4 plus 1/4 is 5/4. But I have to divide by that new power. Be careful with this last thing. You add a 1 to -4, you'll actually be at -3. And then you can divide by -3. Likewise, we're just going to end this antiderivative by saying plus a constant, plus some arbitrary constant. Now, cleaning this up, we can see that 2 divided by 9/4, well, that's the same thing as taking 2 times the reciprocal, 4 9s. That would be 8 9s, v to the 9/4. If I were to go 6 divided by, what we have here, pardon me, just cleaning this up. 6 divided by 5/4 is the same thing as 6 times 4/5. And, you can very quickly see that you'll get 24 over 5, 24/5, v to the 5/4. 3 divided by negative 3 is just a negative 1. Look at that. That's kind of nice. Then we've got a constant here. I do want to state this. This is so very, very, very helpful. If you're ever wondering if you've done this right, take the derivative to double check. You just found an antiderivative. If that's the case, take the derivative. Look, the constant at the end here, that's going to go away. The second to last term, that negative 3 would come down. It would become a plus 3v to the negative 4. You can see what's happening. Term by term by term, it's going to check out. You have found your antiderivative. So always check, especially as you're new here. Look, even this first term, like you had 8/9 times the 9/4. You can see the 9's cancel, and 8 divided by 4 is a 2. So you'd have a 2, and then subtract the 1, you get v to the 5/4. Okay, so let's take a look at this next problem right here. Before you start taking antiderivatives, expand. Expand here. X squared plus 3, well, we'll get x to the 4th plus 6x squared plus 9. What am I doing? I'm just using a plus b. When I square that, I'll get a squared plus 2ab plus b squared. You can see what I just did. I squared the x squared, doubled that middle term, 3x squared gets doubled up, and so forth. Then I'm going to do an I heart math. And, this is even before we do anything. At first glance, you can get kind of scared that maybe you're not going to be able to get an antiderivative here, but it's going to be okay. You can definitely get this thing to work out nice and quickly. Look, I'm even going to rewrite it over here. Here's your f prime of x. X to the 4th over x to the 6th. Hey, that's x to the negative 2. Here I'm going to say plus 6. This is x to the negative 4. Then I'll have plus 9, x to the negative 6. And it's at this point where we can go ahead and find our antiderivative. I'll use capital F of x. But you know what? Because they've already written f prime here, I don't have to use a capital. I can just write it this way. The antiderivative of f prime is just f, isn't it? So now what? Take your negative 2, add 1, and you'll get x to the negative 1, but you better divide by that new power. This will become, adding a 1, you'll get x to the negative 3rd, and you have to divide by that new power. Add a 1 to negative 6, you're at negative 5. You better divide by that new power. And don't forget to say plus c. So we've got f of x equals, well, you could even write this as a negative. And x to the negative 1 is really 1 over x. 6 divided by negative 3 is a minus 2. But that x to the negative 3rd is going to come down here. I'll say minus 9/5, and you can bring your x to the 5ths down here. And don't forget, you've got that arbitrary constant at the end. And that's your most general antiderivative. Of course, you could have written things with a negative exponent at the end. And by the way, it's always a good thing to check and make sure you've done this correctly by taking the derivative to make sure you get back to where you had first started. Okay, example 3, we're going to look at something called an initial value problem. An initial value problem really is going to give you some data here, like f of 1 equals 6. That's saying 1 comma 6 lies on f of x. That's really what that's saying. And the whole purpose for giving that to you is so that you can find out what your constant is. Remember, you've had your plus c in both of these problems. Let's go ahead and just take an antiderivative. I have f prime, so I'll just write f of x. Bump your power up. This will be 8x to the 4th. Divide by your new power of 4. You'll have 12x to the second. Divide by your new power of 2. 3, well, that's kind of like x to the 0. You'd bump that up to just say 3x to the first, divide by 1. Or hopefully you know the antiderivative of a constant like 3 is just 3x. Double check it by taking your derivative quickly. And there you have it. Well, you know, in the previous two problems, we would have stopped right here. We would have said, hey, this is it. This is all great. But right now, we can actually find out what C is. I'm going to let my y equal a 6. I'm going to let my x equal a 1. And we're going to go ahead and work this out. So 1 to any power is just 1 itself. So the right side, we've got 2 plus 6, which is 8, plus 3 is 11. And solving for C, when we subtract an 11, we'll get -5. So that's really what your C value is. I can now come back to what I'd written earlier and say, actually, the function is 2x to the 4th plus 6x squared plus 3x minus 5. I can always double check if I'm right by taking a derivative. In fact, do that real quickly. It just takes a moment. You'll see you're right. And if you want to plug in your 1 for your x, you'll see that your y value happens to be a 6. Well, as we continue on, for example 4, I think you can see that this is a little bit more complicated. It's more complicated in that you have f double prime. So let's go ahead and just take an antiderivative to get f prime. What's the antiderivative of just a 4? Well, a 4x. And then here, my power of 1 is going to get bumped up to a 2, and I divide by 2. And then this x to the third, the new power becomes a 4, and I divide by 4. And it doesn't take you long, hopefully, to see that you have 4x minus 3x squared minus 10x to the 4th plus some constant. Again, you could take a derivative very quickly to make sure that you've done this correctly. But I hope you're noticing that they've given you f prime of 0 is equal to 1. That means f prime itself equals 1 when x is equal to 0. And by the way, x equaling 0 is going to quickly allow you to see that C is equal to 1. So what you can do is rewrite and say f prime of x is really 4x minus 3x squared minus 10x to the 4th. But your C now, you know, is a 1. So I'm going to even rewrite that. I'm going to put my 1 out in front. You know, so we've got that all nice. And then I'm going to do another antiderivative. And why? Because I'm trying to find f. What's the antiderivative of 1? Well, it's an x. Here I'm going to bump up a power of 2 and divide by 2. Here I'm going to bump up a power of 3, divide by 3. Here I'm going to bump up to a power of 5 and divide by 5. And then I'm going to find my other constant. You could call it C2 if you'd like. Could have called that C1. And without too much work, you're going to be able to see this is x plus 2x squared minus x cubed minus 2x to the 5th plus a constant. But they're telling you that f of 0 equals 2. That's your second initial condition. So this left side becomes a 2, while your x is a 0. Wow, look at that. Again, 0 is going to wipe everything out, leaving you just with a C value of 2. What's your final answer? F of x is equal to x plus 2x squared minus x cubed minus 2x to the 5th plus 2. And that's the end of this problem.